Okay, guys, we're going to do homework for 11.2, so let's do it. We're going to do questions 13 through 26, skipping a few along the way. So first off, an error analysis. Dylan compares the volumes of two bottles. What is Dylan's error? So the volume of a rectangular prism is equal to the volume of a cylinder because they have the same dimension. What? No, craziness. No. These corners would be cut off, right? Look at all the voids. Our cylinder, our can, would fit inside of there. And so this has to be smaller. But let's do our calculations. The volume of a rectangular prism is equal to the volume of similar because they have the same dimensions. No. Okay, so let's try this out. The volume of anything in the universe is the area of the base. So the base and the lid match. So that would be base times width. It's a rectangle, right? And however high you stack that. So the volume of the first item is 4 times 4 times 9. Or 144 inches cubed. Now looking at the volume, so that's our prism. Now looking at the volume of our cylinder, we get the volume of anything in the universe is the area of our base. Well, our base and our lid match, and our radius would be not 4. Radius would be 2. Right? All the way across is 4, so the radius is 2. So my base is a circle, and the area of a circle is pi r squared. And however high I stacked those circles. I stacked them 9 high. So that's our height. So pi 2 squared, so 2 times 2, times another 9. So I end up getting 1836 pi. I'm sorry, I'm not getting the same number. So I get 1 inches cubed about. And so that needs, see how that void, it should be less. That's the void around there. Question number 14. Does Cavalieri's principle apply to the volume of cones? Yes, of course. So if I stacked circles that got smaller, and then I pushed it over, somebody pushed it over to the side, do they take away the same amount of space in the universe? I'd say yes. We could also think of this as like if it was a piece of cheese or a Jell-O mold. The object is the same volume. As long as the D, the H, those dimensions stay the same. So if it just deforms itself, it's still the same amount of volume. If it shrunk, of course, that'd be a different story. Okay. Now, 17 through 23. So looking at 17, more Cavalieris. Katrina Bly's 2 vases shown. How do the volumes of the vases compare? They're exactly the same. So Cavalieri's theorem principle states that if two 3D objects have the same height, all right, so I just want to make sure I wrote down same height and same cross-sectional area, I think of that as like a coin. This coin and this coin are the same. At every level, and it's like at every level, yes. Then, yes, same volume. Okay, 18. Alyssa plans a 6-foot deep pond. While digging, she hits rock 5 feet down. How can Alyssa modify the radius to maintain the original volume of the pond? Okay, so original pond was the area of anything in the universe, right? Pi r squared, my base, area of my base, times how high I'd take it. So 3 times 6. So I end up getting 6 times 9, so 54 pi. Now let's compare. We want to maintain that volume. Okay, so this pond is the area of the base, so we don't know what this is, so we'll just call that R. Right? It's a cylinder, so same formula. And however high I stacked it, and it looks like it's 5 high. And I want this 54 pi. I ran out of room there. Give myself a little bit more room. Interesting. So now I could divide both sides by pi, or like I said, using the Lynch swap. All right, we can move this one down and move the 5 down. And notice these cancel. And so the radius squared is 54 over 5. But I don't want to know the radius. I want to know radius squared. I want to know the radius. So I need to take 54, divide by 5, and then take the square root. It's definitely getting a decimal. Okay, so I get the radius needs to be 3.29. 3.29. So that makes sense. Instead of it being 3, I need to make it 0.29 feet. I need to make the radius 0.29 feet longer. So it's the same volume, it's just shorter and squattier, but it's wider. Okay. 19. The instructions for plant foods say to use 0.25, so let's write that out, 0.25 grams per 1 cubic inch of soil, so inch cubed. How many grams of plant food should children use if the planter box is full of soil? So I want my answer in grams. So I want to multiply by inches cubed, so this goes away, and the only thing left I have is grams. Right? That's my plan. So I need to put my volume here. What's my volume? The area of my base times however high I stacked it. Let me check that calculation. Okay, so that's my volume in inches cubed. Now my plan is complete. I'm canceling that, and I can multiply by 0.25 here, and I get 945 grams of plant food to fill it up. 20. If a stack of 40 nickels fits snugly in the coin wrapper, how thick is 1 nickel? Okay, so there's my nickels in here. 40 of them, in fact. The diameter, we don't want that, right? We always need our radius, so I'm going to divide that by 2. Okay, so our volume of our wrapper is a cylinder. The area of my base, which is a circle, times however high, or in this instance long, because I laid my cylinder on its side, I stacked those circles, literally stacking the circular nickels. So my volume is this, 27560. I've got my pi, I got my radius squared, and they want to know, they want to know how high. Okay, so let's figure that out. So let's do this one squared first, this exponent. Oh, wow, I got a big number. So 27560 equals, now I'm going to move my pi down, and then I'm going to move this part down. And when I do, I get my height. All right. Choose 7.60. Okay, so I get 78 millimeters is my height. And that should make sense. So if this diameter is 10, this is 70 of those, 78. That makes sense. Okay. Now, I put 40 nickels in there. So this is similar to the lesson check we did. I got to divide by 40 nickels, and let's find the height of one nickel. Divide by 40. It says round to the nearest hundred. I get 1.95 millimeters. And you know what? I bet you Google it, that's going to be right. Cool, right? Section of 2 flooded control ditches are shown. Which one holds a greater volume? Okay, so the volume. This is a cylinder cut in half, right? So let's do the cylinder first. The volume of the cylinder, but then we're going to cut it in half. So our cylinder is our radius. It looks like our radius is 30. And how high did we stack those circles? See how the circles are stacked this way? It looks like we stacked it 1 foot. I want everything in one dimension, so I'm going to make that 12 inches. So now everything is in inches, right? I need those to be consistent. Okay, so times 12, divide by 2. So I get 5400 pi. Okay, now I can multiply this by pi, and I get this big old number. All right, inches cubed. Now let's figure out how much water this one does. This is my object. It's a trapezoid. So this is a trapezoidal prism, and I stacked my trapezoids this direction. How high? Well, 12 inches high. So what's the area of a trapezoid? Well, I don't know if I've shown you this or not. The area of a trapezoid is the average width. So you add the two bases together, 40 and 60, and you divide by 2, and you'll notice the average width is actually 50 times your height here. That's 30. So the area of a trapezoid is the average width times the average base times the width. So what do we get here? We get 50 times 30, or 150, or 1,500. All right, and then how high did I stack it? So I stacked it 12 inches, stacked it 12 inches. So we still have to multiply by 12 to find our volume. So which one holds more water? This one. Because it's a greater volume. (22) How many 3-inch thick bags of mulch should Naomi buy to cover 100 square feet at a depth of 4 inches? Okay, so here's a bag of mulch. How many 3-inch thick bags? So you can't see this, but apparently they're 3 inches thick. I want everything in the same dimension. So 3 inches, 3 divided by 12 is 0.25 feet. 3 inches is the same as 0.25 feet. Okay, so let's find the volume. So the volume is base times width times height. So 3.2 times 2.5 times 0.25 feet, and this would be in feet cubed. And we get 2. So 2 cubic feet. How many bags of mulch should Naomi buy to cover? So I want to cover 100 square feet. So maybe this is 10 by 10. That's 100 square feet at a depth of 4 inches. At a depth of 4 inches. So what's the volume of that? Well, it's 100 square feet, or 10 times 10, times a depth of 4 inches. So that'd be 400 feet cubed. All right, so how many of those? Let's divide by 2 and find out how many we need. 400 divided by 2, I get 200 bags of mulch. Okay. Now 23. Inez's younger brother will be home in half of an hour. Okay. A half of an hour is 30 minutes, right? And I want everything in the same measurement. If her garden hose flows at a rate of 24 gallons per minute, does she have enough time to fill the pool before he gets home? Okay, so let's see. How big is this pool? The area of anything in the universe is the area of the base. And so the base is a circle, and that would be 4.5. The radius is 4.5. So the area of my base is pi r squared times my height. It looks like my height is 3 feet. Okay, so how big is my pool? Let's find out. Pi times 4.5 times 4.5 times 3. Okay, so that's the volume in feet cubed, but notice they gave me a conversion here. So I want to get rid of feet cubed and cancel because I want my answer in minutes. So I can figure out that this is equivalent to 7.48 gallons. And now I'm going to use this conversion factor because I want to get rid of gallons, right? So I put 24 gallons is equivalent to 1 minute because that's my rate. And look, everything canceled except minutes, and that's my answer in minutes. So I'm going to multiply the numerators and divide by the denominator, 24. I get 59. Oops. Will she get it done in a half an hour? No, it's going to take almost an hour. Almost an hour. Okay. 26 is my last one? Okay. Cool. This is a cool one. This is a prism, right? Because it has rectangular faces. The volume of the prism shown is 70 cubic yards. What is the length? So the area of anything, are you done sick of me saying the area of anything in the universe, volume of anything in the universe is the area of the base. So that's our base. And we have to figure out what is the area of that. Okay, so 1/2 base times altitude. Our base is 3.5. That's nice of them. It looks like our altitude is 5, so that's nice. So I can just plug these in. And then however high you stacked it. Well, we stacked it lengthwise. So you can call that H or you can call that L. Now they said the volume of this is 70 cubic yards. So using a lot of Lynch swapping, we can move the 2 up here by the 70, move the 3 down, and move the 2 5s down, and we should be able to solve for our length. So the numerator, 2 times 70 is 140. 5 times 5 is 25, times 3 is 75, so the bottom is 70. So 140 divide by 75. I'm not getting my answer right. Did I mess something up? Wait, that's not 5 times 5. That's 3.5. Oh, boy. Okay. Rewind. Okay, so the volume is 70, 1/2. The base is 3.5. The altitude is 5. The height is what they want to call the length. Okay, so up here, the 2. Down here, 3.5. Down here, the 5. And that's, there we go. So I get 140 over 5 times 3.5. And we get 8. Beautiful job, guys. See you next time.